Okay, we're going to look at arithmetic next, which is in your books. And these notes need to be taken down. So what does error mean? It is when errors occur due to estimations versus accurate values. And the formula for getting out the error, it's the absolute value of, now see these lines here and here at the end, they mean absolute value lines, and that just means take the positive answer always, because distance can't be negative. So it'll be your accurate answer, take away your observed value or your estimated value, and that will give you what the error was that occurred. So make sure these notes go down into your copies. Now, for example, if the accurate value was 1 centimetre and the observed value was 1.3 centimetres, that means the estimated value was 1.3, then the error would be the absolute value of your accurate minus your estimated value inside your absolute value lines, which means you will take the positive answer even if it works out to be negative. That works out to be minus 0.3 centimetres, and then you take the positive answer, which is just 0.3 centimetres of an error. So that's your first example. Next, we look at percentage error. So you use percentage error to be more precise, because if we explain things in percentages, it means more than if you just give values, because you'd need to know more information with a value. So if I said, is it a large number if I said 4 people smoke? Well, 4 people out of how many is what you would usually ask. So whereas if I said, is 20% of the population who smoke, is that large? You would then be able to say, yes, it is. 20% is a huge statistic. So percentages are used for more precision. Now, the formula for percentage error is the error that you calculated earlier, all over your accurate value, and you multiply it by 100/1 to turn it into a percentage. Okay, so that formula, again, it has to be known off by heart. It's not in any log tables. So that's your formula for percentage error. Percentage error can also be referred to as relative error. They mean the same thing, so just make sure you understand the terminology. Okay, next example of percentage error. Find the percentage error in taking 2.4 centimetres for 2.2 centimetres. So in order to get out the calculated percentage error, you need to put down the formula first. Then you need to decide which value is your accurate value and which value is your estimated value or your observed value. So if they said, find the percentage error in taking 2.4 centimetres for 2.2, that means they incorrectly took 2.4 when it would have been 2.2. So 2.2 centimetres is your accurate value and the 2.4 is your observed value. Put down your formula and then sub into your formula. So to get the error, it's the absolute value, okay, of your accurate minus your estimated value, all over the accurate value, and then you multiply that by 100/1. Okay, and then you tidy it all up. And I've rounded the figure to 9.09%. Now, obviously the question will tell you to give your answer to however many decimal places or to however many significant figures. So just make sure in the questions, if they specify, you are to give it how they ask you to give it. Okay, next we are going to look at tolerance intervals. So tolerance means it's the greatest range of variation that could be allowed. So we all have a certain tolerance for certain things, and the same applies usually in the industrial industry where we're making, in factories, where we're making products, and they'd have to have tolerance intervals. So like if I was making batteries, they will allow batteries to be maybe 0.1 of a centimetre outside of the width restriction of the battery perhaps, and anything that goes beyond that interval has to be thrown into a bin. Okay, it has to be discarded. So that would be a tolerance interval. Basically, how much are you willing to tolerate before which you will throw everything away, okay, or discard things. So it's the greatest range of variation that can be allowed. It is the difference between two measurements, okay, and the formula has to be known off by heart as well. This is the formula for tolerance interval. You have to know it off by heart. It's not in the log tables. So your tolerance interval is x, so some number x, plus or minus a half times the precision of the measuring device. Now, what do I mean by the precision of the measuring device? If we're measuring with our rulers, rulers can be used, the smallest unit on a ruler is millimetres. Okay, Certain other devices that you might be measuring with, the smallest unit might be meters. You'll be told in the question what the measuring device is supposed to be or what the precision unit is. X then will stand for the value that the item or the object is measuring in itself. So it's X plus or minus, because a tolerance interval could go above or below the actual value that is accepted. So that's why it's plus or minus. A half times the precision of the measuring device. Okay, so that's your formula. Make sure you have a box around that and you have to know that off by heart. Okay, so the example there that I mentioned already about your ruler, it has a precision of 1 millimeter, which will be 0.1 of a centimeter. Okay, and your value for X, as I said already, it's the measurement that's taken. Okay, the example here, the measurement of an object using a ruler is 13 centimeters. The precision of the ruler is 0.1 of a centimeter. Find the tolerance interval. So put down your formula for the tolerance interval, which is X plus or minus a half the precision of the measuring instrument, and sub in. So X is 13, plus or minus a half, 0.1, and we're in centimeters. A half of 0.1 becomes 0.5. It's now going to be 13 plus 0.05 or 13 minus 0.05. And that'll give you your tolerance interval, which I've put in square brackets. So the lower interval will be 12.95. The upper interval will be 13.05 centimeters. So basically, if we were producing pencils, and if you get a pencil and the length is anywhere between 12.95 up to 13.05 centimeters, it's accepted. But if the length of that pencil falls outside of the interval, okay, if it's longer than 13.05 or if it's shorter than 12.95, you would have to discard it and it would go into the bin. Okay, so that's just the same explanation I just gave there if you want to jot it down. Next, we're going to look at accumulated error. Well, we know what error is. Okay, it's the difference between an accurate value and an estimated value. Then accumulated error means you're just going to add up all the errors altogether. It's the collection of all the errors, okay, that occurred when you were trying to combine multiple errors. And it usually happens when we start rounding figures. Like if you round continuously throughout a question, you will end up with an accumulated error. So let's say we are totaling up invoices, okay, sales receipts basically from a business. Let's say these are all the accurate values of what the actual invoice, the receipt came to, but these are all the figures after we round them, okay? So if you round them to the nearest euro, so the first one will go to 1,209, the next one will go to 797 euro, the next one will go to 1,002 euro. So if you've now rounded each of these three figures, so if we get the totals, this would have been the accurate total, the total before you rounded, and then this is the total after you round. If I want to get what the accumulated error is, I'm going to take the two of these figures from each other, because basically it's all the errors that occurred when you rounded these figures, so each of those, okay, and the errors that would have occurred because of the rounding, that would tell you what the accumulated error is. But the quickest way would be to get the accurate answer, what it was, get the answer after you had rounded and subtract, and you'll get what the accumulated error is then. So 4 cents, okay, that was the accumulated error after they rounded the three invoice figures.